Okay, so let's kind of complete our starting toolbox here. If you remember back, first week of class when we were talking about how human beings solve problems, I said we use our memory, we ask questions, we do repetition. That's if we had to dumb it down to how all human beings start to solve their problems. We use those things. And then I mentioned something about the mapping that every single programming language, 100% of programming languages have facilities for emulating those three things. And that if you can learn those tools, if you know nothing else about the language, none of the extra little tricks, none of the extra things built into the language, if you just have those three tools, you can solve a big classification of problems in that language. All right. Well, so last time we talked about variables, and we'll go back through these things. I realized we were kind of rushing through stuff just to get into the programming, so we'll recover some of those things today. We went over the memory, talked about variables where we give a name followed by an equal sign. This is the assignment operator. Single equal sign is the assignment operator, equal to its value. And if we recall that Python is a loosely typed language, so we do not give it the type that it's going to hold. So if I was creating a equals 5 in Java, I would say something like int a is equal to 5. I would define it as being a bucket named a built for holding an integer. And then I would put a 5 in there. That's how strongly typed languages would work. A language like Python doesn't require me to give it the type first. I just give it the name of the variable and what I want it to be equal to. If that variable previously existed inside of what's called the variable scope, which we will talk about, if it previously existed, then it will overwrite the current value that's in there with the new value, regardless of type. If it used to hold a string and now I'm trying to put a number in there, now it's a number. Okay? If it's the first time that I'm defining that variable in the scope, it creates the variable for the first time and assigns it the value you're giving it. Okay, so that's how we accomplish memory in Python. Now, right now, we've kind of seen two types, I guess. We've seen whole numbers, integers, and we've seen strings because we've done like hello world and that stuff. But we have character types. We have several other types, and I will talk about those today. But let's at least get these tool sets out here. But what's important for us to recognize in Python, being a loosely typed language, it is again going to be relatively slow. And we have something called a type inference engine. Did I mention that last time? Let's throw a slide up here for this guy. So type inference engines, this is something we don't necessarily have to worry about. We just have to know it exists. All right, so one of the reasons that, let's say, Python becomes relatively slow at runtime is when we try to print out the value that's in A, for example. If I come in here, so I'm going to start using Atom, which we downloaded in class last time, but any old plain Jane text editor will work. I've gone ahead and I've named my file test.py, and by naming it .py here, Atom has determined that I must be writing Python stuff, and it will do some auto indentation stuff for you. That's nice. That's helpful. I'd still encourage you to maybe for a little bit write it by hand, maybe in a text editor that doesn't do the auto indentation stuff to get used to that. That way you'll appreciate what Python does for you. You'll see plenty of examples of that today. But let's just say I created a variable named A, and I started it equal to 5. Is that big enough, or you want me to make it a little larger? That big enough? So we'll create a variable named A, we'll start it equal to 5. And then we'll go ahead and we'll print out A. All right. When this program runs, I'll go ahead and save this. So on the Mac, I hit Command S. On a PC, you'll hit Control S, or you just come up here to File and hit Save. pick your poison. The normal save stuff. I want to go and run this. I'll come out here to the terminal. This file here is saved on my desktop. So here's my desktop. My file is somewhere down in here called test.py. Okay, so that's where I happen to store it on this computer. All right. So when you come out to DOS or your terminal to go and run this thing, you need to make sure that you're sitting at your desktop. Right now I am not, so I'm going to move into the desktop, and now when I type in ls, or on a PC you'll type in dir for your directory listing, you should see test.py somewhere in that list. As long as you do, that means you're sitting in the right directory. Okay, and if you're sitting in the right directory, now you can tell the Python interpreter to go ahead and run this guy. All right, that's a pretty common mistake beginning Python developers make, is they save their file one place, they come out to DOS and they type in Python, the name of the file, and it says it can't find it. You need to make sure you move yourself through the directories to get into the right place, wherever that file lives. So at the end of the day, if you type in dir on PC or you type in ls on a Mac, you should see the file that you ultimately want to run in that listing somewhere. That means you're in the right place. Okay, so I'll go ahead and I'm going to run this guy through the Python 3 interpreter because my machine actually has both. If you're on a Mac, your Mac comes with the Python 2 interpreter, which for, let's call it 90% of what we're going to do in here will be just fine. But every now and then there's a little syntax difference. At some point, I'll probably have you look at the difference between Python 2 and Python 3, but it's kind of an industry war right now. Python 2 was a standard for a long time. A year and a half ago or so, Python 3 came out. So some places are starting to roll over to Python 3. So now there's like a competition between, if you start something new, do you do Python 2 or do you do Python 3? Some of the advantages of Python 2 is that you might have a whole bunch of libraries that have been previously written in Python 2 that you can just use as is, where you're kind of having to maybe wait for some third-party libraries to be converted over to Python 3 before you can use them. But at this point, we're a year and a half in, most of that stuff has already made the jump. So it's kind of less of a competition right now, but we're still maybe at the tail end of which of those two do I choose. And as an example, if you go to Zybooks, Zybooks has two different Python books. They have Python 2 and Python 3. So I chose Python 3 so we'd have the most up-to-date stuff. But if you're on a Mac and you didn't install Python by hand after last class, and you just use the one that's built in, it's probably going to work for you for at least a little bit before you finally hit some weird syntax difference between Python 2 and Python 3. But if you see on my machine here, if I type, since I have both, if I type in Python and I press tab a couple times, it kind of shows me all the things it thinks it's going to find. So this original Python is actually the Python 2.6. Then I have Python 3, which is actually Python 3.6. So this is the interpreter I'm going to use. This is the guy I actually installed recently from the python.org website. Okay, so it didn't overwrite the old one. It just gave me a second version of Python. All right, so I'll use Python 3 here. So I make sure I'm running it through the correct interpreter. And all these are computer programs. I just happen to be running them from the command line rather than double-clicking on an icon on my desktop. Okay, so Python 3, the name of my file is test.py. I'll go ahead and run that. We get our 5. Okay, and as a reminder here, we go back into Atom. I create a variable named A, set it equal to 5, and then I said print that dude out. Now, what happens here is A must get resolved to its value. All right. Now, in any programming language, whenever we use a variable, we can think of a variable as kind of like a placeholder. Okay. That guy at runtime is going to become the value that lives within that variable. Now, Python actually has one additional step. Not only are we going to resolve the value that's in there, but before we do that, we need to resolve what kind of animal is in the box. Okay, so before we actually unpackage A and get to the value that actually lives in there, we need to figure out what kind of value is that. Is that a number? Is that a string? Is that a character? What am I going to be dealing with after I open up this box? Then we'll open up the box, and that value will be of that type. Now, it happens to be that print can handle all the different types. We can print numbers, we can print strings, we can print chars. Print knows how to do all those different things. So it's kind of relatively unimportant in this particular problem. But if I were doing some math, for example, if I were saying something like B is equal to A plus hello, as an example, let's just say I didn't necessarily know that A held a number. Okay, I thought A held a string. All right, and I want to do some adding stuff with these guys. It's not actually how it works in Python, but that's okay. This will show us our problem. This plus sign is the addition operator. All right, so when I try to do addition here, it's going to have to figure out, is whatever's in A something that addition can be applied to? All right, and it's going to determine that it's not. Well, A is, but this other side is not. Okay, so that type inference engine will figure out the types of both sides. It's going to say, oh, well, this guy is a string. Okay, this guy is a int. The plus sign cannot be applied to integers and strings combined. That doesn't work. So if I go and run this guy, we get an unsupported operand type for plus, int, and string. Okay, it doesn't know how to apply that operator to those two different kinds of animals. All right, but this is our evidence of the type inference engine. It figured out that A was an int, and it figured out that hello was a string. It classified both of those guys down to their types, and that took an extra step. So if we go back to our original examples, this is like pulling that Tupperware box out from underneath the bed, peeking in there and seeing what's in there. Okay, it takes some time. Most of the time, that's not going to be something that we need to concern ourselves about. Again, computers are really, really, really fast, but it is a reason to say that loosely typed languages are relatively slow compared to strongly typed languages because of some of those extra steps. But we also then have the advantage of not having to write the extra thing in front of the A or the B here. We don't have to dictate what kind of value it's meant to hold. So maybe you can say that makes life a little bit more efficient for the programmer. Now, having said that, though, another, and I think I've mentioned this before, but another, let's say, perk that some people will say is, nothing keeps me from doing this. Nothing says I can't say A equals 5, print A, and then A equals hello, print A. Let's go ahead, we'll run that real quick. So there's my 5 and my hello. So I created this variable here. This was the initial definition of it. So that's when it was first brought into existence. And I gave it the value 5. Then I printed it. So it's going to figure out, okay, what kind of guy is this? He's an int. Am I allowed to print ints? Yes, you are. Okay. What int is actually in there? 5. Print the 5. We saw that happen. Then I went and I changed the value that lived in my variable A to be hello, a completely different type. You could not do something like this in Java or C# or C++ because those are strongly typed languages. Okay? I can't throw a string into something that was built for holding an int. But in a loosely typed language like Python, you can do that. Okay? I would argue it's kind of more of a trivia type piece of information because most people would not do something like this. Because usually we're going to name our variables something meaningful. Usually we might say that this guy is mynum. Okay, then we'll print out mynum. All right, so we named that variable something meaningful to us so that we knew that the value stored in there was our number. Okay, so even though this is legal, we might say that this doesn't make a whole lot of sense, right? To overwrite mynum with something that's a string, we're kind of, it's like, you have the Tupperware container that says taxes on it and you throw shoes in there or something like that. That you might lose those shoes. It might take a good hunt through the house to finally find those shoes. All right, so, this is probably the better example, naming the variable something that's kind of meaningful. This is legal code in Python. But as human beings, we can say that this line right here just kind of logically doesn't make all that much sense. Why am I putting a string into something that seems to have been built, even though Python didn't make me define what it was meant to hold? I named it such that it's supposed to hold a number, right? So we might say that this could be at the very least confusing later on. But Python lets us do it. So my argument would be just because Python lets us pull this off, no harm, no foul, this wouldn't typically be something that a programmer would do. So even though Python lets you get away without defining your types, typically you're going to name your variable something meaningful. Something that you originally put a number in is probably always going to end up holding a number. So you might make the argument that the only real benefit of this guy is it keeps you from having to type an extra little thing before it or something like that. It saves you a little bit of typing, and you put that burden onto the interpreter to have to do a little extra work at runtime. But most of the time, we don't care. This is stuff that happens so quickly, it's meaningless. Okay, so while this is legal, it's probably not going to be something you see very often. We would probably instead do something like this. Maybe my string, and we print out my string. We have a variable for holding our number, we called my num. We have a variable holding our string called my string. Move on with life. All right. But again, this type inference engine is going to first look inside of this bucket. Before it actually gets the value, before it resolves the value from a variable, it's going to say what kind of value is in there, and is the current context in which I'm trying to use it legal? Am I allowed to work with that kind of value here? Am I allowed to print something of type integer? Am I allowed to print something of type string? If yes, then I'll go ahead and resolve it to its value. If no, then I'll scream and say you're using illegal stuff. Okay, so programming languages do a lot of screaming at us. So that's going to be one thing that's going to be frustrating for you early on, is you're going to get a lot of errors. And what a beginning programmer typically does is they flip out and they don't read the error message. When we had that error message before, when I tried to say maybe we say my num is equal to my num plus hello, as an example, okay, which we saw was an error before. A typical beginning programmer might come out here, they might try to run this, they see the error, don't even read it. That just looks like a wall of crap to them. Okay? They don't read it, they just go back and say, oh, I'm just going to randomly change some stuff. I must have done something wrong. So let's go and change things. Where admittedly, and this is probably one of the better error messages, but admittedly one of the skills you learn as a programmer is reading error messages and distilling what they mean. All right, so this guy is officially complaining about line 2 here, but you can't necessarily take that to the bank. Is just because it's complaining about line 2, the problem is there or above. It could be your error is actually somewhere above there and it wasn't discovered until line 2. In this case, our program's short enough that not a whole lot happened before line 2. Okay, so we can, a good place to start would be on line 2. And then it shows us what line 2 looks like. And then it gives us some information about what that error is. So in this case, it's saying this operator, the plus sign, can't be applied to an int and a string. I look at this here and I said, oh, well, this guy must be an int. Well, my variable name should help me with that if you give your variables meaningful names. So then I will say, well, what was I expecting the answer of that to be? I wrote it fine, but maybe when I wrote it, I was thinking I was doing one thing when actually I was doing something else. Now I look at this and I say, oh, okay, well, that's an integer and that's a string. What was I hoping this was going to do for me? Okay, if you have trouble answering that, you're probably writing something wrong. All right. But in any case, you should always read these messages first to at least give yourself a chance at knowing what the issue is. Because too often what ends up happening is the beginning programmers come back here and just start changing things. And the danger with that is, you change something enough times, it might start working. But then you have no idea what actually fixed it, right? You hurt your back or something like that, and then you take some Advil, you're icing, you're putting your knees up, stuff like that, and all of a sudden your back feels better. You have no idea which of those 3 things actually benefited you, right? Maybe it was all of them, maybe it was none of them, but when all is said and done, that's your new MO. You just do all that stuff, and hopefully it gets fixed. So you want to approach this, whenever you make a change to your code, you want to have a reason for it. Even if you're not super confident in your reason, you want to be able to say, okay, well, I'm going to change this line because I think I actually needed to do this. Then change it. If you're wrong, you're wrong. You'll learn something from the next error message. But try to give yourself that little time to assess the error message you're getting rather than just react. Okay? So let's get this guy out of here. All right, so we'll call that tool number 1, defining variables using variables in our language. Okay, so again, we can figure out we can go to Home Depot and get those 3 tools. How do we do memory? How do we ask questions? How do we do repetition? We can all of a sudden solve a lot of problems in using a programming language. We're going to be limited because we don't have all the extra power tools, right? We can only do so much around the house with a screwdriver and a saw. Okay, we don't have all the power tools and table saws and stuff like that, but we can still solve several things around the house. So that's what we're going to try to start with here. All right, so any questions about defining a variable and putting values in there? Good enough. All right, so I'll just put a sentence here. Type inference engine. This guy's job is to figure out what kind of value lives within a variable before it actually resolves that value. And resolving the value means we've converted the variable into its value and now we're trying to use it. Right? Bad things could happen. All right, so that's our memory. Then we were looking at asking questions, and we're going to talk some about Boolean expressions today. Right? But let's go ahead and write an example in here so we have some code we can work with. So the way we ask questions in Python is with an if statement that came from C. If, and notice this guy gives us a structure we can go ahead and fill in the blanks with. So that's something that these text editors made for programmers do for us. The fact that I named my file something.py, Adam now knows that I'm working in Python, and when I type in if, it gives me some options of I'm sorry, I was going to click on the other one. It gives me a couple of starting points for my if statement. Right. This guy deals with whether or not something is the main method. So this is a little bit different type of if statement, but it gives you templates for these 2 different kinds of things. And we will get to this, but not important for us right now. Again, I would encourage you for right now not to use built-in stuff. Type as many things as you can to give yourself the opportunity to memorize them naturally. I don't think you should just sit around and try to memorize every piece of syntax. You'll end up memorizing the structure of an if statement, the structure of a for loop, the structure of all these different things just by typing them. So too much cut and pasting is going to be detrimental to you, even though it'll make your life a little bit easier in that exact moment. Okay? So give yourself a little extra time. So if open parenthesis, the opening parenthesis is not required in Python, but I always, 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 always use it. Every other language uses open parentheses here, so it's going to behoove you to use it. Plus, I think it just makes things look structurally better. Okay, now what goes inside here is something called a Boolean expression. All right, now let's go ahead and define a Boolean expression. What that guy means. Boolean expression is any expression that boils down to a single value of true or false. Any expression that boils down to a single value of true or false. And that's kind of an important thing there. Similarly to when you get an error message and we just react, flip back over to our code and start changing crap. When you glance at code, another skill you're gonna gain as a programmer is being able to read code, and you'll find that skill will come significantly ahead of being able to write it yourself. Okay, so what I expect to happen for maybe even most of this semester for most of you, since even though each week you're going to be getting better, we're going to be moving on to more difficult material, right? So it's kind of, you're always playing catch up maybe. But when you see the solution in class, you'll be able to read it and say, oh, well, that makes sense. But you'll also kind of feel discouraged, like, I don't know that I could have written that myself. That comes later, all right? So you will get competent at looking at other code and knowing what it does before you get comfortable doing it yourself. You'll get bits and pieces, but you'll constantly be feeling like the early thing is there's something wrong with the Python interpreter or something like that. My code looks exactly like your code, yet it's not working. It's probably you're a little short of exactly. You're missing a colon or something like that there, which is kind of maybe what makes programming kind of frustrating. You know, all that syntax is important. I had a couple people in one of my other classes right now. You know, they sent me some code, and everything about the code was right, except one thing was capitalized when it shouldn't have been. You know, and in real life, when we're working with English, when another human being is reading that, that's fine, right? You know, might say, well, I think this should be capitalized, but you can read it. You haven't lost meaning out of it because somebody didn't use a capital S or somebody used a lowercase s or, you know, whatever. But in programming, we have to be precise. Almost every single programming language is case sensitive. So there is a difference between a capital S at the beginning of the word string and a lowercase s at the beginning of the word string. Those are two different things. Okay. Similarly here in Python, those are two different variables, even though they have the same name. That make sense? Just because this guy starts with a capital M, he is different than the first one. Right, so something to keep in mind with really all programming languages. I can't think of one programming language right now that isn't case sensitive. They probably exist, but nothing modern. Okay, so with that in mind, a beginning programmer often looks at something and at a glance they make a decision. They decide what that means. And sometimes things are a little bit more than meets the eye. So for instance, you might see something that looks like A less than B and C greater than 5 and D equal to C or something like that. This big long thing here actually is a Boolean expression, assuming A, B, and C hold numbers in this case. And I'll explain why. But the point is that at a glance, this looks like kind of a complex series of things. But ultimately, it boils down to a single value of true or false. Okay, and just to kind of flesh that out, if we say A is equal to 3, or whatever I hit, B is equal to 7, I need a C. We'll do C is 6, and we'll do D is 6. And wish this thing wouldn't fix my capitalization. Okay, there we go. So something like that. The first thing the type inference engine is going to go through here is going to say, what kind of value is A, B, C, D, and 5? It's going to determine all those guys are ints. Then it's going to say, are these operators applicable to ints? It's going to say, yes, they are. Then it's going to say, okay, so now we're going to resolve those guys and perform those operations there. Then it's going to ask the question about these operators, which we'll talk about in a few minutes, but that's the AND operator. So ultimately, this is asking 1, 2, 3 different questions and ANDing them all together. We're going to say, is 4 less than 7? Yes. So that's going to be a true. And is C greater than 5? Is 6 greater than 5? Yes. So that's a true. And is D equal to C? Is 6 equal to 6? Yes. So that's a true. So then the type inference engine is going to go back through and is going to say, what are the types of these guys? These guys are all Boolean values. Can the AND operator be applied to Boolean values? Trust me, yes, it can. That's what it's for. We'll talk about it in a few minutes. So since the answer is yes, then we'll go ahead and evaluate this. So we'll say true and true and true ultimately boils down to true. A single value of true or false. That makes sense? So at a glance, we might say that this guy looks complex. But after we resolve it, it ultimately boils down to something simple. But we have to be able to go through that process. Go ahead. If one of them was false with an and, this whole thing would be false. But I'll talk about ands and ors here in a second. So worry less about that right now, more just about that scary looking things can be simple things. Is kind of the punchline of this slide right now. And where this maybe even becomes more complex is when we start writing our own methods, our own functions to do things. Because a function might have 500 lines of code in it, but it has one value that it returns. So we might be saying, is something less than a function when called on this value? And you look at that and say, well, that's a function. I can't compare a number to a function. But that function, after all of its lines of code, will ultimately boil down to a single value. And that single value maybe is legal for doing that comparison. Make sense? Okay, so it's kind of important to slow ourselves down a little bit and try to determine what an individual line is actually doing. Okay. So we have our arithmetic Boolean operators. These guys you already pretty much know. That's your less than or equal to, greater than or equal to, not equal to, and equal to. So these are the guys that work on math stuff, arithmetic stuff. All right. So we've all seen these before in various math classes, correct? This isn't anything new. These are some of the tools that will allow us to build Boolean expressions. Now, the ones that you maybe haven't necessarily worked with, they would be kind of introduced in maybe a logic course or something like that, is our logical Boolean operators. And these are going to be and, or. There's actually a couple of ones. I'm going to just keep it simple with these right now. Because these are, let's say these are the ones you'll use 99% of the time as a programmer, these two. There's also a thing called an exclusive OR that exists, but you can actually accomplish it with just these two. So let's not muddy the waters right now. So an and, when applied to two Boolean expressions, returns true when both sides are true and false otherwise. And this is something we've dealt with in real life. If I say today that it is sunny and warm, that's a false statement, right? It's still chilly outside. It's, I don't know, 29 or something like that right now, 31. 31 is not warm by any measure, right? Okay, so that's a false statement, even though it is pretty sunny right now. Now, if I would have said it's sunny and cold, that's a true statement, because both of those things are legitimate true statements. Okay, but since I used and there in the middle, both sides had to be true in order for the statement I said to be true. Make sense? With an or, when applied to two Boolean expressions, returns true when at least one side is true and false otherwise. So one side, both sides, doesn't matter how many are true. As long as one of those sides is true, the whole thing will be true with an or. Okay? So I'm not sure this is something we'd actually say in real life, but if I said it's sunny or cold out today, technically that is a true statement. It is sunny. The cold part's false, so that's true or false. At least one side is true, so the whole thing's true. Okay? So that's our ands and our ors. So we'll use those in Boolean expressions, potentially coupled with arithmetic ones. So as an example, I'm using the arithmetic Boolean operators here as well as the logical Boolean operators here to string together Boolean expressions. So the logical ones operate on Boolean values on either side. The arithmetic ones operate on numeric values on either side. All right, so that's, again, kind of important here. This is a number, but this expression right here ultimately boils down to a Boolean, true or false. So that's why we are allowed to use the at symbol there, or the and symbol there, to compare this guy to this guy, because those two sides ultimately will become true or false values, which we can apply and to. That make sense? All right. So Boolean expressions, any expression that boils down to a single value of true or false, and we can say, generalistically speaking, they come in different shapes and sizes. All right, but ultimately, if you give them a chance, it'll be anything that will ultimately boil down to that single value of true or false. And we'll have plenty of practice with these, but that's what we're looking for here. So for an if statement, what goes inside of these parentheses here is any legal Boolean expression. So that could be something that's very simple looking. It could be something that's very scary looking, but it's something that ultimately will boil down to a single value of true or false. All right. So maybe I'll put in here my num less than 10, for example. My num will, first the type inference edge will say, what kind of value is this? It's an int. Am I allowed to use this operator with ints? Yes, I am. Well, am I allowed to apply it to an int and an int? Yes, I am. So let's go ahead and get this dude's value. His value is 5. Is 5 less than 10? Yes, it is. So this whole thing will ultimately boil down to true after all that work. Okay? So we put the Boolean expression in there, then we put a semicolon. I'm sorry, we put a colon, not a semicolon. Okay? That colon at the end of lines is going to be a common occurrence that we run into in Python. You'll start seeing the pattern here. Now, when I press enter here, you'll see that Adam goes ahead and indents for me. All right, if you're not using a text editor that does that, you'll have to indent on your own, either press tab or press space a few times. Whatever, just make sure your indentation is consistent. But Adam will do it for you. Again, another advantage of a text editor like this, but don't take that for granted. Understand that those indentations are required in Python. Okay, so if my num is less than 10, we'll go ahead and print woot, let's say. We'll just leave it at that for right now. I'll take away that second my num so we don't muddy the waters here. So we define a variable called my num, set it equal to 5. We'll go ahead and print it out, so we'll see a 5. Then we'll ask the question, is 5 less than 10? It is, so we'll print out woot. Save this. Go out here. We'll rerun our code. There's our woot, because 5 is less than 10. If I come in here and I change that guy to 50, 50 is no longer less than 10. So the output of this program is just going to be 50. Because we'll come down to this question, we'll say, is 50 less than 10? It is not. So we will not execute the code underneath this. So the output of this program will just be the 50 from that first print statement. Make sense? So that's that second tool, asking questions. Now, we can optionally put an else in here. So we can say, if this thing is true, do this, otherwise do something else. All right, so we can say print LOL or something like that. Okay, so right now, this guy is going to print out LOL because 50 is not less than 10, so this will boil down to false. So since this boils down to false, we will execute the else, assuming there is an else there. So this will be 50 followed by LOL. If I change that 50 back to 5, now it'll be 5 followed by woot. So the else only occurs when this guy is false. This guy only occurs when this guy is true. There's our 5 and our woot. Okay, so just another tool. Went to Home Depot. We got this if statement. This is how it works. All right. You'll get used to applying it to problems, but effectively right now we have two things in our toolbox. How do we make variables and remember things? How do we ask questions? All right. Now we're going to add one more thing to our toolbox. Last part here is repetition. We have two loops that we're going to look at here. One is the for loop. One is the while loop. All right. For loops lend themselves to counting type problems. While loops lend themselves to problems where we do not know how many times we need to repeat. So, for example, if we want to count between 1 and 10, for loop's a pretty good option. If we want to do something until somebody presses a key, while loop's a pretty good option. We don't know how many times we're going to repeat something until some condition is finally met. It might never get met. All right, let's look at for loops first, because a lot of the early problems we'll be looking at are going to be counting problems. I suppose one truth we might say here, though, is that you can solve any problem requiring loops with either of these loops. You could build the same logic of a for loop with a while loop. You can build the same logic of a while loop with a for loop. You can accomplish it. All right, but I would say you're probably going to, if you had the go-to tool, the loop you will likely use most of the time is probably going to be a for loop. Typically, when we are repeating things, we're repeating things some number of times. Okay, do something 50 times, do something 100 times. For your homework assignment, you're going to be doing something 1,000,000 times. Okay, so you probably wouldn't want to write 1,000,000 lines of code. You'd rather wrap the 2 lines of code inside of a for loop that goes through 1,000,000 times. Make sense? That's the power of loops. So let's look at the syntax for a for loop. So I'll go ahead and backspace. So again, if I were to put, just to show this, if I were to put, I don't know, what's this guy? It's going to be greater. 2 different print statements here. And I go ahead and change this guy back to 50. Both of these lines are associated with this else because both of those lines are indented underneath that else. Okay? So I will, when I ask this first question, is 50 less than 10? No, it's not. So that's false. We will fall down here to the else. We will do everything that is under the else. So this will print out 50, followed by LOL, followed by greater than 10. Okay, all of that stuff happens under the else. Now, that shouldn't be confused with this. So we see the output there, 50, LOL, greater than 10. If I backspace that, and I run this again, I'm going to get the exact same output. So we might believe that, oh, well, those things are the same. So I'll run that again. I've got the exact same output again. But what happens if I change this back to a 5? If I change that back to a 5, and I re-indent that guy, all it's going to print is 5 followed by woot. But if I go ahead and unindent that line, this guy no longer belongs to the else. He's now just part of the program. So now it's going to print out 5, followed by woot, and then it's going to go ahead and print out this line, because this line has nothing to do with that question. It's just a line of code sitting out there. That's part of the program. So it will print out greater than 10, which is not what we wanted. Make sense? So that indentation is very important, that we kind of group those things together correctly. Okay, so we'll leave that code there so you have some sample code to work with for your homework. Now let's look at a for loop. So for loops, like I said, usually lend themselves to counting type problems. So we're usually working with a number being taken on a voyage through a range. So for example, I could say for I in range 0 to 10. There's that colon again. I'll go ahead and print out I. So what this is going to do is it's going to define a variable named I, start it off at 0, and take it to 10 non-inclusive. So I will be the value 0 through 9 each time through this loop. So this is going to print out 0 the first time, then 1 the second time, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9. Then we will add 1 to 9. 9 becomes 10. Is 10 less than 10? It's not. So we will fail out of this for loop and not print out the 10. So at the end of the day, there is an implied Boolean expression in here. This effectively says, as long as I starts off at 0, keep going as long as it's less than 10, add 1 to it each time. Okay? There is a mechanism for adding more than 1, but let's not muddy the waters with that yet. Right now, we're just incrementing by 1. Okay? So this should print out 0 through 9 for me. Here's my 0 through 9. And if I change this to 10,000, now it'll print out 0 through 9,999. I went through a lot of times. For your homework assignment, you're going to be going to 1,000,000. So this will go from 0 to 1,000,000. Actually, I think your homework assignment is, I might say 1 to 1,000,000, whatever it is. So this will start at 1. It'll go all the way up to, but not including 1,000,000. So if you want to include 1,000,000 for right now, you go to 1,000,001. So this will go 1 to 1,000,001. So this will be all the numbers between 1 and 1,000,000 inclusive. And we'll just print all these out. This might take a second to run. Okay. Now, interestingly, though, just as more like a little trivia thing, the reason that took a second to run, or took several seconds to run, is not because Python is slow. It's because each time through this loop, we are printing something out. And even though we view printing as being a fairly quick thing, you know, everything up to this point seemed to happen instantaneously, right? When you take the operating systems course, you'll learn that I/O is actually quite expensive. It's very difficult for your computer to write a lot of stuff out to the screen. Because to do I/O, you have to interrupt the CPU. So what's effectively happening is the CPU is number crunching your low-level code here. Then all of a sudden you say, wait, I need you to print something. The CPU says, okay, well, my work is done here, so I'm going to go ahead and pass that guy off over here. Let the input-output subsystem do all of its magic. And then when he's ready to do some more number crunching thing, which is what I do, he can get back in line. Well, we're doing that 1,000,000 times. Right? And we're not doing a whole lot of math in the middle. All right, so that's why it was taking so long, as we were switching in and out of the CPU over and over and over and over again, and that's slow. All right, that makes some sense? All right, so that's our for loop. Similarly, all right, let me shorten this down again just so it's slow. I'll go ahead and write a while loop for us just so we have it. So I'll say I is equal to 0 while I is less than 10, print I, and then I is equal to I plus 1. So we'll add 1 to I each time. So that'll be the equivalent while loop to this for loop above. Right, so we're pulling off the same code twice. Well, actually, it's not quite equivalent right now because this guy's still starting at 1. Now it's equivalent. Now they're the same. Okay? So, memory, asking questions, repetition. Your homework assignment, it's already up on Blackboard, is to go through all the numbers between 1 and 1,000,000 and count how many of those numbers are evenly divisible by, there's like 4 numbers, I think I have like 9 and 18 or something. There's 4 numbers that are in the assignment. So the number of numbers that are evenly divisible by any of those. So you're probably going to use an OR. Okay, if it's evenly divisible by this guy or this guy or this guy or this guy, you're supposed to count how many of those guys are evenly divisible by at least one of them. All right, so you're going to need a variable to count. You're going to need a loop that goes through all the numbers you're testing. You're going to need a question each time through the loop asking, is the current value evenly divisible by my choices here? That's going to be a Boolean expression. We check for evenly divisible using the modulus operator. Remember we talked about that last time, the percent symbol that gives us the long division remainder. All right, so I'm effectively sending you home with a toolbox with a couple of things in it, giving you a problem that can be solved in terms of just those things. Now go and do it. All right? Make sense? Questions, comments, concerns, bribes, I'll go ahead and paste this code up on Slack just so you have it as a starting point to manipulate or whatever. But again, try not to copy and paste too much. Get used to typing it yourself. And also, feel free to work in groups if you think that'll benefit you. I'll find out on the exam if you're not learning this stuff. Yeah, you want to have Python downloaded on yours. I mean, I guess you could potentially do it inside your.
You said this would be.
Yeah.
So which one?
Well, so you're on Windows, so you want the Python 3.
This one.
Yep, latest Python release.
And then.
There's probably just a download thing at the top, I'm guessing. Python 3 is the latest. Okay, here's the. So. Probably want that one. The executable installer would be my my guess. Are you? Let's see, what processor is this? A fairly new machine?
Within the last.
Core i3, you're fine. So since you're a Core i3, you are a 64-bit processor, so that will work. But the 32-bit stuff would work too. So x86 is 32-bit, x86 64 is 64-bit, but either of them is fine.
Okay.
Do the 64.
Perfect.
And that guy you can just double-click on and he'll install, and then I would think you would have the little DOS-y thing like I've been doing.
Yeah, sounds good.
Okay, so when I'm here, how do I...
Stop the recorder so I don't forget.